Alright, hello again. This is chapter 1.2, problem 2, and the directions state identify the family, graph the parent function, and state how they differ. Alright, so basically what we're doing is we're identifying it, we're graphing the parent function, but then we're going to, the last page, state how they differ, is we're actually stating the transformations. Okay? So here we go. First things first. This is a nice straight line, right there. Okay. However, it has a slant to it. Remember, a constant is either like that, or a constant is either like that. Has no slant. It's either straight up and down or straight left and right. So this is linear. This is a linear function. Okay. And they want us to graph the parent function. So the parent function of a linear is f of x, or simply y, equals x. So x, y, let's do -2, -1, 0, 1, 2. Well, if x equals y, well then all your y values are going to be the same as your x's. So -2, -1, 0, 1, 2. Right? Go up here and plot your points. -2, -1, 0, 1, 2. And you notice the pattern. If you want to just follow the pattern on out to the edge, that is actually a really good practice. And use a straight edge if you can. Again, I can't because of my program. At least I haven't figured out how to yet. And you get a graph that looks like that. Okay. Now, the graph that they have given us, I'm going to go ahead and give you the equation for it real quick. This graph is f of x equals -1/4 x plus 8. Alright? Now, there are two things going on there. First things first, we have the -1/4 out front, and we have the 8 out back. Alright, the 8 out back, what that does is that is a translation, or we're going to call it a shift. And it shifted up 8 units. Okay, it took the entire graph and moved it up 8 units. Okay, the 1/4 is, this is like dividing by 4. Okay, this -1/4 actually does two things. The negative does one thing, and the 1/4 does something else. The 1/4 is like dividing by 4. And remember, if you go back to your vocabulary, we have what was called a vertical shrink. That's when we divided the y's by something. All right, this is a vertical. I'm just going to write vert for vertical. Shrink by 1/4. We shrank it by a factor of 1/4. And last but not least, that negative. That negative is a reflection. Because we multiplied by a negative, that's called a reflection. And it went across the x-axis. Now this one's a little tricky. Because they think, well, which axis did it go across? Did it go across the x, or did it go across the y? Well, basically what happens, it affected my y's. All right? It took all my y values, but by affecting the y, it moved it, I don't know what just happened there. It moved it across the x. If you move a y goes up and down across an x-axis. So it affected the x-axis. If it was inside, which we'll talk about what inside means in just in a little bit, inside it goes left and right. It goes left and right across the y-axis. Okay? But those are the three transformations. All right. Letter B. Let's talk about that one. Letter B. It looks like a big V, and they're straight. It's not curved like a parabola. A parabola would look more curvy. So this one is an absolute value. Go away, go away. Somebody's texting me on my iPad. Is an absolute value. Okay? It's an absolute value function. So let's graph the parent function. The parent function would be f of x equals the absolute value of x. And if you've forgotten that, you can just go look up to your notes. That's fine. Let's give a table of values. X, y. All right. -2, -1, 0, 1, 2. The absolute value of 2 is a positive 2. The absolute value of 1 is a positive 1. 0, 0, 1, 2. You just plug in your x's and get the y. Okay, that's telling you we just took the 2, stuck it in for the absolute value, and got, oh look, it's positive 2. Don't go that far. And then we'll plot it real fast. Ooh, I messed up my scale on the last one. Because 1, 1 is really right there. That's 1, 2. I didn't pay attention to my scale, Mr. Hunter. Okay, so 0, 0 is -2 is right there. Positive 2, so it goes right there. There and there. This is -1, 1. This is 0, 0, 1, 1, 2, 2. And if you want to continue it on out, remember it makes that straight line all the way out. And you get a graph that looks like, see how straight I can make this. When you see me write on the board, you'll realize that that is utter perfection. And there's your absolute value. All right. Now, this graph right here, I'm going to go ahead and give it to you as well. The transformations is f of x equals 5 times the absolute value of x. All right. Now, I think what they mean on this is just state how they differ, just kind of give me an idea of what's happening. I don't think they want the formal, like this would be the formal ones over here. Basically what happened is this is a vertical stretch. All right, we took all these points and we stretched them by a factor of 5. You don't have to draw those arrows, but that's what happened, is we stretched them out by a factor of 5. We multiplied the entire function by 5. So this is a vertical stretch by 5. Or you can say by a factor of 5. That's what it is. All right? Have at it.